Hello guys, today we are talking about the tangent and normal questions, okay? So let's move to the first part about tangent and normal. So first we can say the tangent function or the tangent value can be considered as dy over dx, right? So the differentiation for y also can be considered as the gradient of the tangent here. And also we can say that normal is always perpendicular to the tangent. So that the gradient of them has a relationship that is where m normal equals to negative 1 over m tangent, right? Okay. So for some problems in the A-level P3, it's very similar to the problems in A-level P1, or even you learn about the IG for the math, I believe you can understand for this problem, okay? So if we have three kind of very typical classic cases like the tangent parallel to x-axis, that means that differentiation always equals to zero, right? Because here it's always parallel to x-axis, so it's always a flat slope. There's no gradient here, so that is why differentiation equals to zero. And secondly, we can say if the tangent is parallel to y-axis, that means that the dx over dy equals zero, or there's undefined values here. There's undefined values here, okay? Undefined here. And when it's a normal tangent gradient, we can say that the differentiation equals to 1 and the y differentiation equals to negative 1 here, okay? That is it. Okay, so for example, like here, is that a curve is given implicitly, and we're told that find the 2 points where the gradients are has a normal and is 1, okay? So the method here is for you to first find the differentiation here and in terms of x and y, and then find the gradient m or dy over dx equals to 1, or then you can calculate it for the differentiation is negative 1, and then solving x and y using original curve equations, okay? So for example, like here, for the question 1 and question 2, let's solve it together. So for first problem, so x cubed, if you want to try to make a differentiation on both sides, so you said x cubed differentiation for 3x squared, right? And this way, you can find y is also a function here. So 3x squared y can be considered as plus 6xy, right? Because it's uv equals to u differentiation v plus uv differential, right? So 6xy plus 3x squared, here's for dy over dx, right? And then minus here is for 3y squared times dy over dx, right? Because it's a complex function, because y is a function of x. If you want to calculate the differentiation of x, you have to also times the differentiation here, right? So it equals to 0 because 1 divided by x is always 0. You can just consider here that it's for x and y. It is 1, so every part, the gradient equals 0, right? There's no gradient anymore. And then we can put 1 and 3 into it. So that is for 3 plus 18 plus 3 times dy over dx. And here's minus 27 and times dy over dx equals to 0. So we have 24 dy over dx equals to 21. So dy over dx, or differentiation here, equals to 21 over 24 equals to, here is for 7 or 8. So even you have the differentiation, you have the gradient here, and you can also calculate the lines function here, right? Okay, it's not very difficult, right? And for second problem is that for the curve x squared y squared minus x times y cubed equals to a cubed, shows that there's only one point where the tangent is parallel to x-axis, right? So you can just make a differentiation on both sides. So for x squared y squared, you can set the differentiation here is for u times y, and you can just make it as u differentiation v plus uv differentiation, right? So here is for 2x times y squared plus here is for x squared times 2y times dy over dx. And also for second is can consider as u times v is for minus y cubed and minus 3 times xy squared times dy over dx and equals to 0 because a cubed is a constant. So the differentiation here equals to 0. So we can just try to written that as this method, like because you want to find in the tangent where parallel to x-axis, right? That means dy over dx always equals to 0, right? Also to 0. So like we can say that it's 2x times y squared. Here is 0, right? And here 0 is minus y cubed equals to 0, right? And then you can say that it's y equals to 2x. It's our final answer. So we can say there is only one tangent obey the rule. So that is y equals to 2x. And you can even put a value into it to find the exact coordinate of that, okay? So because y equals 2x, you can put it into it. So it's x squared times 2x squared minus x times 2x cubed and equals to a cubed, right? So this value is for 4x power 4, and here is for 8x power 4 equals to a cubed, right? So we can calculate for, maybe here a is a negative, so that is for a cubed over 94, total square root for 4, right? Total square root for 4. And that is for the x coordinate. And also you can put into y equals 2x, and you'll find the y coordinate here, okay? That is for this problem. So I hope you can truly understand it for these problems, like first trying to differentiate it. Just consider y as a composite function, and then everything can be very easily to calculate, okay? That's for this problem. Okay, that's for our lesson. So see you next time. Bye.